Alright class, so it's week number 6. In last session we had discussed about small changes in chapter number 16. Small changes we had discussed, and also chain rule, right? Now in today's class we are going to start next chapter, that is chapter number 17, and in this chapter we are going to discuss about higher derivatives and its applications, right? So there are certain steps that we need to follow in all the questions, so I'm just writing down the steps here, and it will be very useful for you if you write all the steps in the beginning, so you will know that for each question what is the pattern that we are going to solve all those questions and examples. Alright, so the first step is whenever we are requested to find stationary points, for stationary points, keep in mind that we need to equate dy over dx equals to 0, right? And by placing dy by dx equals to 0, we need to find out the stationary points. That is the first condition. Now it says higher derivatives, so now we have greater value and lesser value. For maximum and minimum value, we need to find d square y divided by d square dx square, right? And it refers at double derivative. So in order to find out what is the highest value or the lowest value of the function, so we need to derivate the function again to find out d square y upon dx square, right? And if your d square y upon dx square greater than 0, d square y upon dx square lesser than 0. If d square y dx square is greater than 0, that means the function has minimum value. And if d square y upon dx square is lesser than 0, that means it has maximum value. Alright, so these are the important conditions that we are going to use very oftenly in this chapter. So first you need to write down in your notebooks, and for that part you have a time of 40 seconds, so start. Alright, once you had noted down the important points, now we are going to discuss how we are going to apply those points. So for that part I have taken example number 1 from your book of the chapter 17 and exercise 17.1 we have. Alright, it says that diagram shows part of the curve y equals to x plus 4 upon x. So let me just write the equation is x plus 4 upon x minus 2. For x should be greater than 0 at the end the point L2, 2 on the curve. As you can see that we have a point here. Show that dy by dx equals to 0 at point L. So what you need to do, you need to find dy over dx. Once you had find dy by dx, then you need to place the value of x 2 here, because it says at L and the value of x at L is 2. Right, so your answer must be equals to 0, so you need to show that. Alright, and for that part you have a time of 60 seconds, so start. Alright, before derivate the function, what I will do, I will take LCM here, so that will be x square plus no LCM, I think there is one short method I have, that will be x plus 4x minus 1 minus 2, right? What I had done, I had just placed this x in the numerator, so it will be with the negative power. We had the arranged equation of y. Now dy over dx we have is 1 minus 4 divided by x square, right? That is my dy by dx, and now I need to place value of x, that is equals to 2. So dy by dx equals to 2. It will be 1 minus 4 divided by 2 square is 4, 4 and 4 cancel, it leads to 1 minus 1, and that is equals to 0. So we need to show the same, that dy over dx equals to 0 at point L 2 comma 2, and we had shown it, right? For the next part, B. Observe the change in gradient as x increases through 2. So what is the value of x? What is the value of gradient if the value of x is greater than 2? So let's suppose that if x is equals to 3, that means the question is asking what is the gradient of this portion here, right? So if x is equals to 3, we have dy over dx is equals to 1 minus 4 divided by x square, right? That will be 1 minus 4 divided by x is 3, 3 square is 9, and it will be 9 minus 4, it leads to 5 upon 9, that is your dy over dx at x is equals to 3. So what you can deduce with these increasing values of x, if you observe the part here, 1 minus 4 upon x square, right? If x values is lesser than 2, let's suppose if it's 1, so you have dy over dx lesser than 0, right? Why? Let's suppose hypothetically if you place 1 here, so that will be 1 minus 4 and it leads to minus 3, right? At x equals to 2 you have 0, we had proved it, and x is equals to 3, that means greater than 2, we have positive values. It means that when you have x values that is lesser than 2, this curve has shown the behavior of positive values because dy by dx is lesser than 0. At 2, it's a stationary point, dy by dx equals to 0, and greater than 2, it has a minimum value because dy by dx is greater than 5 upon 3. Alright, not greater than 0. Alright, so these are the functions you have, and in short I can say that dy over dx changes sign from negative to positive, right? And I have shown you here that when your value is lesser than 2, it has a negative value dy by dx, at 2 it's 0, and greater than 2 it's positive, so it changes from negative to positive. Alright, so if there is a confusion, so not to worry about it because it's new and it's our first class of the topic higher derivatives. So let's take one more example. It's example number 2. The diagram shows part of the curve. We have equation y equals to 3x minus x cube for x should be greater than equals to 0. Find dy by dx and show that h is a stationary point. How you know that h is a stationary point? It means that at point h dy by dx should be equals to 0. Alright, so if dy by dx equals to 0, how you are going to prove that? It's quite simple. First you need to derivate the equation, and for point h you can see that its x value equals to 1. Alright, so now you have a time of 90 seconds to give it a try, so start. Alright, so now it will be dy by dx equals to 3 minus 3x square, right? Dy by dx at x is equals to 1, it will be 3 minus 3x is 1, 3 minus 3 leads to 0. So dy over dx equals to 0, it means that h is a stationary point, right? Because we have a condition that at stationary point dy by dx equals to 0. Alright, after that in the second part it says that show that dy by dx changes sign from positive to negative as x increases through 1. So when you have value greater than 1, what should be the value of dy by dx? We can observe it. If I write the equation here that y equals to 3, not 3, main equation is 3x minus x cube, right? If I take x common here, so that will be 3 minus x square, and I find the derivative of y, so dy by dx, it's 3 minus 3x square. If I take 3 common here, so it will be 1 minus x square, and that is your identity of a square minus b square. So I can say that it's 3, 1 minus x and 1 plus x, right? From if x increases through 1, so my gradient show the attitude from positive to negative. That means if x is 2, x is 3, x is 4, the answer will be negative, and you can observe it just right here, right? The positive bracket will always be positive if you have higher values of x. Let's suppose x is 2, it will be 3, x is 5, it will be positive 6. But what about this one? If x is 3, it will be minus 2. If x is 4, it will be minus 3. So with increasing values of x, you have a gradient negative, right? Your gradient changes its sign from positive to negative, and that's what you need to show in that part. Alright, so after that I'm going to start your exercise 17.1 book questions. It's 17.1. Find by calculus the stationary point of the curve y equals to x square minus 4x plus 6. Observe the changes in the sign of the gradient of the curve and determine the nature of the stationary point. Alright, first thing, for stationary value, or you can say for stationary point, we know that dy over dx equals to 0. So first you need to do it. Find dy by dx, place it equals to 0, minus 4 equals to 0, 2x equals to 4, and x equals to 2. So we know that at x is equals to 2, we have a stationary value, that means dy by dx equals to 0. And the value of y at x is equals to 2. So at x equals to 2, you have y equals to 2 square is 4 minus 4 2s are 8 plus 6. So equals to 4 plus 6, 10, 10 minus 8, it leads to 2. So the stationary point we have is 2, 2, that is the value of x and y, right? Now after that it says observe the change in sign of the gradient. What does it mean? We have dy over dx equals to 2x minus 4, right? At x equals to 2, we know that dy over dx equals to 0. At x lesser than 2, let's suppose we have x, instead of x we have 1, so 2 ones are 2, 2 minus 4, it will be minus 2. So dy by dx equals to negative. At x should be greater than 2. Let's suppose that x, the value of x is 4. So 2 times 4 is 8, 8 minus 4 is 4. So dy by dx is positive, right? Is greater than 0. So the sign change we observe is from negative to positive. Alright, so moving on towards the next question. Question number 2. It says that a curve is defined by y equals to x square x minus 2 whole square. show that dy by dx equals to 4x into x minus 1 times x minus 2. Now you need to first expand it with the identity, or after that you can multiply it or you can apply u into v, that's totally up to you. So I am giving you the time of, if I apply the identity here, a square minus 2ab plus b square, x4 I am going to multiply, minus 4x cube plus 4x square, right? So that is y. After that I can find dy over dx, it equals to 4x cube minus 12x square plus 8x, right? We can simplify it further. We can take common here, and that is 4x. Now inside the bracket it will be x square minus 3x plus 2. So that is a quadratic equation and you can solve it by middle term. So it's 4x bracket x square minus 2x minus x plus 1. Alright, now it's 4x. Inside the bracket it will be x. I am taking common here, so it's x minus 2, and here we have it's positive 2. So x minus 2 minus 1 and x minus 2 as well, right? After that 4x bracket I can take common again x minus 2 and the leftover part is x minus 1. Alright, so this is what I need to show in the first part and we had shown it. After part A, it's part B. Find the coordinates of stationary points on the curve. For stationary points, we had discussed it. The condition is what? dy by dx should be equals to 0, right? For part B, we need to apply dy over dx equals to 0. dy by dx we had find out it's 4x bracket x minus 2 x minus 1 equals to 0. Now you need to solve it and you have a time of, if you multiply the brackets, right, if you multiply all those brackets and made your equation, then it's a wrong initiative for this part. What you need to do, since all those three brackets are multiplying and they are equals to 0, so you need to equate to 0 separately. And what does it mean? I will say that 4x equals to 0, x minus 2 equals to 0, x minus 1 equals to 0. So x equals to 0, x equals to 2 and x equals to 1. These are the values of x. Alright, now it says find the coordinates. Coordinates means the value of x and y. So when x is 0, if you place it in your equation of y, so y is 0. If x is 2, then y is what? 2 2s are 2 minus 2 will be 0. So y is 0. And when x is equals to 1, so y is equals to 1 minus 2 minus 1 square is 1. Alright, so these are the coordinates. So in your final answer form, I can say that the coordinates are 0 0, 1 0 and 2 0. These are the coordinates for stationary points. Alright, so after question number 2, moving on to the next question, question number 3. A curve is defined by y equals to 2x cube minus 9x square plus 12. Show that dy by dx equals to 6x times x minus 3. Now you all know that how to derivate that function, so you need to show that dy by dx equals to, so dy over dx, it's 6x square minus 9 2s are 18x. The derivative of constant is 0. I can take 6x common here, so the leftover part is x minus 3 and that is your answer. That is the first part. For part B, find the coordinates of a stationary point on the curve, right? So how you find a stationary point? Simply dy by dx equals to 0, right? So dy by dx we had find out it's 6x times x minus 3 equals to 0 again. There is no need to multiply these two equations. If you are going to multiply, then it will end up with the maybe a wrong solution, because the more solution you are going to do, the more chances that there is going to be any mistake here. So what you need to do, you need to just equate it. So 6x equals to 0, x minus 3 equals to 0, x equals to 0, and x equals to 3, right? Since it says find the coordinates, now you need to place the value of x in your main equation. Y equals to 2x cube minus 9x square plus 12 at x equals to 0. If you place x equals to 0 here, so y is 12, at x equals to 3, so y equals to 2, 3 cube is 27 minus 9, 3 square is 9 plus 12. 27 2s are 54, 9 9s are 81 plus 12. So we can solve it. 54 plus 12 and minus 81, it gives you the value of minus 15, right? So the coordinate we have is 0, 12 and 3, minus 15. These are the coordinates. For part C, it says observe the change in sign of dy by dx. X increases through each of the stationary points and hence deduce the nature of the points. For nature part, we need to apply the second differentiation. And how you are going to do that? You have dy over dx is 6x square minus 18x, right? So here I am attempting part C. Dy over dx equals to 6x square minus 18x, right? So if I derivate it one more time now, that will be d square y upon dx square. Now I am derivating it again, so 6 2s are 12x minus 18, right? That is the differentiation of dy by dx, 6x square minus 18x. Alright, after that we have two values of x, that is 0 and 3. So we need to place x equals to 0 here and we need to place x equals to 3 here. Substitute those two values in d square y upon dx square x and find your answer. D square y upon dx square, it will be negative 18, and x equals to 3, d square y upon dx square equals to 12. 3s are 36 minus 18, it leads to 18. Alright, so what you can conclude with this result, we know that when you have negative sign, it means that at this point we have maximum value, and when you have positive, it means that we have a minimum value. Alright, so you can conclude that the point 0 12 is basically is providing or giving the maximum value, and the point 3 minus 15 is basically the minimum value function. Alright, so I think that it is quite enough for today class. I hope that you have a better understanding of higher derivatives, how to find a stationary value, and how to identify that a curve has a minimum or maximum value function. We have studied that part in today's class. Inshallah, next class we are going to start 17.2. Till then, take care and Allah Hafiz.